Let's talk about the second law of thermodynamics. And before we get to the definition, let's just start by thinking about the kinds of processes which naturally occur, right? So some processes occur naturally, others don't. And some examples of processes that occur naturally, we could think about a gas expanding to fill a given volume. So if we had a gas in a box with a partition and the gas was initially over here, we remove the partition, the gas would expand that all. Another one would be that a hot object cools to the temperature of the surroundings. Right, so if we have a cup of coffee and we leave it sitting on our desk all day, it won't be hot coffee for very long. Another example might be a chemical reaction which moves in one direction naturally but not in another. So you might think about the burning of a candle, for example. In each of these examples, what we see is that the process is moving in a particular direction, and we can call this the spontaneous direction of change. And one thing that we can say about this is that it does not require work to be done on the system. Right? So we can actually see these processes go in the opposite direction. So for example, we could compress the gas. It's not impossible. We could also heat the coffee. And we could, by doing some work, make the reaction run in the opposite direction. So all of these things are possible. Now, one thing to note about this word spontaneous, look at that, is that spontaneous tells us only something about the direction or the tendency of the system. So we could think about that this is what will happen. But it tells us nothing about the rate. So for example, diamond transforming to graphite is a spontaneous reaction, but the rate is so slow that we don't actually have to worry about it. So spontaneous, what will happen, this is the study of thermodynamics, and study of the rate, this is what we would call kinetics. In these processes that we call spontaneous, we can say that the entropy of the universe is always increasing. So this sort of brings up the question, what is entropy? I'll elaborate on this in a different video, but for now we can say that entropy is a measure of disorder. So spontaneous changes move in the direction of increasing disorder of the universe. increase the disorder of the universe. And we'll talk about this more in different videos, but you can remember that the universe is broken up into the thermodynamic system and the surroundings. So it's possible that the system can have a decrease in entropy, but the change in entropy of the universe has to always go up. So we can think about some examples which illustrate this idea of increasing disorder. And one of those might be of a ball bouncing. So if I drop a rubber ball, that ball will bounce and bounce and bounce and bounce, right? And finally it will come to rest. The energy that the ball had will be transferred into thermal motion of atoms in the floor, and eventually our ball will be sitting here on the ground. But we would obviously never see a ball sitting on the ground spontaneously start bouncing higher and higher. So that's one example. If we want to know sort of what is the spontaneous direction of change, we want to look for the direction of change that leads to the most dispersal of energy. And just as in the example with the ball, we see that the reverse processes don't happen because energy doesn't become localized and initiate a process. So we know that a state which has a certain amount of energy that's dispersed has higher entropy. And this finally now brings us to our statement of the second law of thermodynamics, which says that for any spontaneous process, that means one that will occur without extra work being done, the entropy of the universe, so the disorder of the universe, so we can see that entropy is different from energy. The first law told us that energy was conserved. The second law, however, tells us that entropy is a quantity which can increase.